Hello, this is a review video for your Chapter 5 test in college algebra. And the first question I'm going to review for you says to solve the system by graphing. So this says, first of all, y equals negative x plus 8, and then y equals x plus 2. Then we're going to make a graph of those two equations. So the first equation has a y-intercept of 8, and it has a slope of -1. So that means that it goes down 1 and over 1, then down 1 over 1, and it'll keep on going until finally it's going to hit the x-axis at 8 as well. So that's what that graph looks like. Then the next graph has a y-intercept of 2, and it's going to have a slope of 1, so it goes up 1 over 1, up 1 over 1, up 1 over 1, and so forth. And it ends up hitting that line right there. And if you look carefully at this, when you do this on the computer, and you plot 8, and then you go down 1 over 1, and you plot the next point, and then the line draws on the computer. And then when you click 2 on the computer and go up 1 over 1 and plot the next point, you'll notice that the second line crosses through the first line. So let me make a big red dot right there. Now on the computer, look carefully at where it crosses, and you'll notice that that point where it crosses is at 3, 5. So I'm just looking at the computer real quick, and that means that the solution to the system of equations is 3, 5. So the point where the lines cross each other is the solution to the system of equations. So the graph itself of those two lines is your first answer, and then the solution 3, 5. That ordered pair is your answer to the second part of the problem. Okay, now let's try problem 2. Problem 2 says that 9y equals 63 minus 7x, and then it says 1/9 x plus 1/7 y equals 7. So it says to use a substitution to find it. All right, well, first of all, let's actually try something else. Before we do a substitution, let's find the least common denominator of this equation, which is 63, and let's multiply by that. So if I do 63 times that equation, I'll get 63 over 9x plus 63 over 7 times y equals 7 times 63. And 63 over 9 breaks down into 7. Yes. So 7x plus 63 over 7 breaks down into 9. Then we'll still have 7 times 63 on the right side. So let's see, that's 420 plus 21, 441. Now let's look at the equation up here on top, and let's rearrange that. Let's put the negative 7x over on the left side. So I'll get positive 7x on the left side, and then plus 9y, and then equals 63. Now wait a minute. 7x plus 9y equals 441 when I simplified when I simplify that equation and I get this equation, and then I get this equation, I get 7x plus 9y equals 441. But when I rearrange the top equation, I get 7x plus 9y equals 63. So 7x plus 9y cannot equal two different things. So that means the solution is nothing So the solution set is empty, and this is an inconsistent set of equations because it consists of a contradiction to itself. So there we go. Now let's look at problem number 3. Okay, so let's clear the page and start on problem number 3. So Mrs. Wilson, it says Ms. Wilson invested $28,000 in 2 accounts. So basically, you have 5%, which is represented by X. Then you have 12%, but you don't know how much goes into the 12% account, but you do know that she invested a total of $28,000. So what that means is if somebody invests $28,000, then the amount that would be left in the second bank account would be equal to $28,000 minus the amount that she had put already in the first bank account. So the total amount of money that she gets is equal to $2,590. So what this means is that if you took 0.05 times X, and you also added 0.12 times 2,800 minus X, 28,000, 28,000 minus X, then it would equal the interest that was gained, which is $25.90. So just a second, actually. So something happened, and I accidentally deleted my problem, but I think I can remember it though. I believe it said 0.05. This is problem number 3. 0.05 times X plus 0.12 times 28,000 minus X equals 2,590. So if I multiply that together, I just get 0.05X, there we go, plus 0.12 times 28,000, which is equal to 3360 minus 0.12 times X equals 2590. So this is kind of fun. So let's take 0.05X minus 0.12X, and we'll get negative 0.07X plus 3360 equals 2590. Now I'm going to subtract the 3360 from both sides. And then I'll get negative 0.07X equals, so what's 2590 minus 3360? Negative 770. Now I'm going to divide both sides by negative 0.07X. By negative 0.07. And then I'll get that to cancel. So X equals whatever this is, which turns out to be 11,000. So that means if you go back to the beginning of the problem, that means that the person invests $11,000 into the bank account at 5% interest. Now remember the other bank account, 12% interest. 12% interest was equal to 28,000 take away the 11,000. So if I do that on a calculator, 28,000 minus 11,000. Oh, well, actually, I didn't even need a calculator. So 28 minus 11 is 17. So this is going to be $17,000 left in the 12% bank account. So that's how you do that problem. Perfect. Now let's go to problem 4. Good job. Perfect. So, sorry. So problem 4, this just wants us to plot 3 different dots. So it's good to sketch x plus 2y minus z equals 4. All right. So there's the z value, the z-axis going up, the x-axis going right, and the y-axis coming out that way. So what you're going to do is, first, you're going to find the x-intercept. Hold on, that z is kind of hard to see. You're going to find the x-intercept, which if you just only look at the x, you'll get x equals 4. So you'll have 1, 2, 3, 4. Like that. Now let's find the y. If you just only look at the 2y and you set it equal to 4, you'll get 2y equals 4, so y equals 2. So the y-intercept is 2. So 1, 2. Then you look at the z alone, the negative z. So if you say negative z equals 4, then you'll get z equals negative 4. So the z-axis actually goes down below like that. So you go down 1, 2, 3, 4, down to z equals negative 4. And then you basically just connect them with kind of a little triangle like that. So that's just sort of filled in like this. So that's the graph of that problem. Now let's try problem number 5. Problem 5 says, solve the system of equations 3x plus 3y plus z equals 4, and then x minus 3y plus 2z equals 0, and 8x minus 2y plus 3z equals negative 8. So first of all, what we're going to do is we're going to put the simplest equation, which just has x alone with nothing in front of it. We're going to put that up at the top. So I'm going to write down x minus 3y plus 2z equals 0 up at the top. But then what I'm going to do is I'm going to take this equation off to the side. Actually, I'm going to bring it up here actually. See, I'm going to take the original middle equation and I'm going to multiply it times negative 3, right? So I'm going to take row 2 times negative 3 and put it up beside the top row. So if I do that, if I take the second row times negative 3, I'll get negative 3x, positive 9y, negative 6z equals 0. But now what I'm going to do is add that on to the top row. So I'm going to take this row together and add it onto the top. So what I'm really doing is this. I'm taking row number 1 plus row number 2 times negative 3. So when I do row number 1 plus row 2 times negative 3, then my new row 2 is equal to 3x plus negative 3x is 0x. And then 3y plus 9y is equal to 12y. And z plus negative 6z is equal to negative 5z. 4 plus 0 is equal to 4. Now I'm going to do something similar to that. I'm going to look down at the bottom row. No, sorry. Hold on. I'm going to look at the middle row again, actually. And I'm going to multiply the middle row now by negative 8. So row 2, this time, times row 2 times negative 8. And I'm going to put the result down right over here. So row 2 times negative 8 is equal to negative 8x, positive 24y, negative 16z equals 0. So what I'm going to do with that one now is I'm going to take that result and I'm going to add it to the bottom row of the original problem. So in other words, what I'm going to do now is take the third row of the original problem plus the second row of the original problem times -8. And the reason I'm doing that is because if I do -8 times this x, it'll knock out that positive 8x. So that's the reason that I'm doing this. So let me go ahead and add those two blue equations together in the third row. So if I do that, 8x plus -8x goes away. -2y plus 24y is equal to 22y. And then 3z plus -16z is -13z. -8 plus 0 is just -8. Perfect. Now, let's do this. Let's take the second row. We need to try to get the second row close to let's see. Let's take the third row of this new equation right here, row 3, and let's add row 2 times -2. What would that do? Well, that's going to be row 2 times -2. Row 2 times, if I take row 2 times -2, then it'll become equal to -24y plus 10z equals -8. Now I'm going to take that row 2 times -2 and add it on to row 3. So I'm basically going to take this row 3 and that new thing and add them together. So what that makes me get is 22 plus -24y is -2y. And then 10z plus -13z is -3z. And then -8 plus -8 is -16. That's great. Now, you see what I'm going to do? I'm now going to take this one right here, and I'm going to multiply it by +6. So I'm going to take that times +6. And the reason I'm doing that is because when I multiply that by +6, it's going to make -12y. When I add that onto the 12y that I have, it's going to eliminate that equation. So if I take this times 6, I'm going to get a new result, which is -12y and -18z equals, let's see, -96. -96. Now I'm going to add that to the second row. So I'm going to add this row onto this previous second row to get the new second row. So it'll be, or actually to get the new third row. So 12y plus -12y is equal to nothing. -5z plus -18z is equal to -23z. And then 4 plus -96 is equal to -92. See that? It's amazing. Now, the top row is x minus 3y plus 2z equals 0. So I've got a new system of equations like that. But this is almost solved now, because what I can do is I can divide the last equation by -23 on both sides. If I divide it by -23 on both sides, then I'll get, let me erase this stuff over there. Then I will have the third equation solved, which is the goal. And then you can solve the second equation, then you can solve the first equation. So this third equation now becomes just z equals, let's see, -92 divided by 23 equals 4. So z equals 4. But then what I'm going to do is I'm going to plug in z equals 4 into the second equation. So we'll get negative 2y minus 3 times z, which is 4, equals negative 16. But you see, negative 3 times 4 is equal to negative 12. So you can write this and put down negative 12. But then you see that negative 12 on that side, you can add 12 to both sides, and then this will be gone, and you'll just get negative 2y equals negative 16 plus 12. Negative 16 plus 12 is actually negative 4. So you see, you really get negative 2y equals negative 4. But if you divide both sides by negative 2 on both sides, you'll end up with y by itself equals positive 2. So you just get y equals positive 2. Now we'll do the same thing with the top equation. We'll work through that a couple times. So the top equation says x minus 3y, but now we know the y is equal to 2 plus 2 times z, but we know z is 4, equals 0. So let's simplify that. So negative 3 times 2 is really just negative 6. So change that to a negative 6. 2 times 4 is just equal to 8. So change that to an 8. Negative 6 plus 8 is just equal to positive 2. But a positive 2 on the left side becomes a negative 2 on the right side. So if I move that over, I'll just get x equals negative 2. So the solution is negative 2, comma 2, comma 4, because you have to find, negative 2, comma 2, comma 4, you have to find x, and then y, and then z. Let's go ahead and try to review problem number 6. So problem number 6 says x plus 4y minus 5z equals 5. And then negative x minus 4y plus 5z equals negative 5. And then 2x plus 8y minus 10z equals 10. So this is problem number 6. It looks like this. So of course, our first step is to get rid of as many x's as possible. We're just going to leave this top equation the same as it is because it already has x alone at the beginning. But I'm going to take this number row 2 and I'm going to add row 1 onto it, because if I add them together, then the x's are going to go away in the second equation. So I'm going to take that, I'm going to add row 2 to, and row 1 in the middle, so it'll be no x's, no, and then the 4y plus negative 4y goes away, that plus that goes away, so then in the middle row, I'll just get 0 equals 0. So the top row stays the same, x plus 4y minus 5z equals 5. But the second equation, when I add row 2 plus row 1, the second equation just becomes 0 equals 0. All right, now let's do something with the bottom equation. So in the bottom equation, if I take row 3, right? Row 3, and that's the bottom one. If I take row 3 and I add on row 1 times 2, you see, if I take, no, not row 1 times 2, I'm sorry. If I take row 3 plus row 2 times 2, well, what's row 2 times 2? Row 2 times 2 is equal to, okay, row 2 times 2 is equal to negative 2x and negative 8y plus 10z equals negative 10. That's row 2 times 2. Now, if I take row 3, right? And if I do row 3 plus row 2 times 2, then I'll end up with 2x plus negative 2x. That's nothing. 8y plus negative 8y, that's nothing. And then 10z plus negative 10z, that's nothing. And then 10 plus negative 10, that's just 0 equals 0. So what this means is our equation for z is z could equal anything, right? So z, what they say is they just say that z equals z. And of course, the statement that z equals z just means that z is what it is. And then the second equation, which is the one we're going to try to use to find y, is just 0 equals 0, which is just a, that's just always true. So y equals y. So y just is what it is, right? Wait, hold on, my pencil's not working anymore. Just a second. So that just means y equals y. Well, if y equals y and z equals z, then the only equation that actually means anything is the first one. So that just means there are infinitely many solutions. Whoops, hold on. Infinitely many solutions. And any solution would work as long as the first equation, which is the only one that really matters, as long as the first equation is true. So the solution set could be any numbers, x, y, and z, but not any numbers at all. It could be only any numbers which satisfy the equation that 1x plus 4y minus 5z equals 5. So that's kind of a strange looking solution, but the solution could be any points along the line, the graph of the line 1x, actually the graph of the plane, 1x plus 4y minus 5z equals 5. Now let's try problem 7. All right, so 7. Problem 7 says the sum of three numbers, in other words, when you add the three numbers together, the sum of the three numbers is 10. And then it says the sum of twice the first number plus 5 times the second number plus 6 times the third number is equal to 50. And then it says the difference between 6 times the first number and the second number is 0. Find the numbers. Well, first of all, we're going to use this last equation, 6x minus y equals 0. I can add y to both sides of that and just easily get the equation 6x equals y. So that means I can go to the other two equations and rewrite the problem. Every time that you have a y, you're going to change it to 6x. So you'll have x plus y, but instead of writing y, you're going to say 6x. And then plus z equals 10. Then you'll go to the second equation. It says 2x plus 5y, but instead of writing y, you're going to write 6x, and then plus 6z equals 50. Now let me simplify those equations. So x plus 6x is really 7x plus z equals 10. And then 2x plus 5 times 6x, well, 5 times 6x is 30x. 2x plus 30x is 32x plus 6z equals 50. And then we now need to try to solve that. So what I'm going to do is take the top equation right here. I'm going to take row 1 times negative 6. And I'm going to put that down beside row 2. So row 1 times negative 6 is equal to negative 42x, and negative 6z equals negative 60. Then I'm going to take row 2 plus row 1 times negative 6. And then if I do that, I'll get a new second row, which is equal to this second row, right, row 2, plus this, row 1 times negative 6. So when I add those two green equations together, I'll get negative 10x, and then 6z plus negative 6z is nothing. And then equals 50 plus negative 60 is negative 10. All right, then the top row stays the same, 7x plus z equals 10. Sorry, that looks like 16 equals 10. But if the bottom row is just negative 10x equals negative 10, I can divide by negative 10. And I'll just get x equals 1. And I can plug x equals 1 into the top equation. So 7 times x, which equals 1, plus z equals 10. So that's 7 times 1 is really just 7. Then I can subtract 7 to that side. So z equals 10 minus 7, which equals 3. So I've gotten x equals 1. And I've also gotten z equals 3. And then last but not least, I'm going to go to this equation. Right here, I'm plugging my x. So remember, y equals 6x, which equals 6 times 1, which equals 6. So that means that y equals 6. I put them together into order. The first number, of course, is x. So the first number that they want is x. So the first number is 1. The second number they want is y, which is 6. The third number they want is z, that's equal to 3. So and the solution to the problem is 1, 6, and 3. Now let's try problem number 8. Perfect. So problem number 8, it says y equals square root of x, and then y equals 3x. So we have to solve these equations. Well, of course, the first thing I'm going to do is just, since y equals 3x, I'm going to plug that into that other equation, and I'll get 3x equals the square root of x. And then I'm going to square both sides. 9x squared equals x. Then I'm going to subtract the x to the left side to get 0 on the right side. Then I'll factor out an x, leaving me with 9x minus 1 equals 0. Then I'll set this x equal to 0, and I'll set 9x minus 1 equal to 0. Then I'll add 1, and 9x equals 1. Divide by 9, I'll get x equals 1 over 9. So I get x equals 0 and x equals 1 over 9. But that's not all, right? When you find a solution to an equation like this, you have to solve for x and you have to solve for y. So when x is 0 and then x equals 1/9, those represent two different points. And I have to find the y value of both of those points. But the y value, remember, is y equals 3 times x. So when x equals 0, y is equal to 3 times 0, which is also 0. And when x equals 1/9, so when x equals 1/9, y equals 3x, which equals 3 times 1/9, which equals 1/3. So the solutions are 0, 0, and then comma, and then 1/9 and 1/3. And then you have to find a graph that touches each other at those 2 points. So the graph that touches each other at those 2 points and shows a square root and then a line. So that touches itself at 0, 0, and the lines cross again at 1/9, 1/3. So just pick the graph that looks like that crosses itself at those 2 points. All right, now let's try problem number 9. So problem number 9 says 3x minus y is less than 3. So first of all, let's find the x-intercept. So the x-intercept is 3 times what would give you 3. which of course would be 1. So the x-intercept is basically going to be 1. So put a little dot here at 1. Now technically it's actually an open dot. It doesn't really matter for this on the computer when you're doing it right here. So I'm going to draw an open dot. Now then you look at the negative y. So when does negative y equal 3? Well, negative y can only equal 3 if y is equal to negative 3. So the y-intercept is negative 3. The x-intercept is 3. The y-intercept is negative. No, I'm sorry. The x-intercept is not 3. The x-intercept is 1, because 3 times 1 is equal to 3. And then the y-intercept is negative 3, because negative times negative 3 is equal to 3. Now, notice that this inequality right here is not a solid inequality because it does not look like less than or equal to. It only just looks like less than, right? So because it's less than, that means it's not a solid line. It's not going to be a solid line. Well, so if it's not a solid line, that means it's a dashed line, right? So you're going to draw a dashed line, which you can choose on the line graphing tool. You're going to draw a dashed line through those 2 points. So the way you'll really do it is on the computer, you'll just choose the line tool, and then you'll choose the dashed option, and then you'll just plot this point, which is 1, 0, and then you'll just plot this point, which is 0, negative 3. And once you plot those 2 points, it's going to draw the dashed line for you already. Now comes the interesting part. You have to shade the line. So you have to shade either on the left or on the right. So you have to think carefully. So look at the 3x. 3x, it says, is less than that. So if x is less than that, that means that x has to be below that, right? Now, which side of x is below? Well, x goes left to right. So the left side of x is below, right? So you're going to shade the left side of this graph. And then you shaded the x values that are below 3. So, well, you're actually not just x values below 3. You've shaded the part of the x values that's below that inequality. So the inequality itself is represented by the area that's to the left side of that dashed line. Okay, now let's try problem number 10. So problem number 10 says to graph y is less than or equal to 5. So this one's actually a flat line. This is nice. So y is less than or equal to 5 is just a flat horizontal line at y is equal to 5. Okay, so we're going to draw, just go to 1, 2, 3, 4, 5. Just draw a point at 5, and then just keep going towards the right. Move to the right, but don't go up or down. Just keep moving straight. The line is just a horizontal flat line. That's just y at 5. But then now this one has a y at the beginning. So y is less than that inequality as well as being equal to it. So if y is less than it, you're going to choose the fill tool, and you're just going to click anywhere below the line. And then the computer will fill in the part underneath the line. All right. Now we're going to do number 11. Number 11 says y is greater than absolute value of 4x minus 16. And then it says y is less than or equal to the square root of 16 minus x squared. Perfect. So technically, the first graph is basically kind of like a V shape that starts out at negative 16. So the first graph is kind of like a V shape that starts out at negative 16, like that. And then it kind of goes upward. Yep, it goes upward like this with a slope of 4. So it goes, let's see, upward like this, and then upward like this. And then that's what this first graph looks like. Then, and by the way, your shading, it says y is greater than that. So you're shading above that graph. Now the second graph, y is less than or equal to square root of 16 minus x squared. That one can be thought of as a circle, but it's only the top half of a circle with a radius of 4. So if you square both sides, you'll get y squared. If you change it to an equation as well, you'll get y squared equals 16 minus x squared. So then you'll get, bring the x to the left, you'll get x squared plus y squared equals 16. So that's a circle with a radius of 4, but because the square root can only be positive, this is just the top half of a circle with a radius of 4. So you're going to actually have a circle right here, and it's going to have a radius of 4, and it's going to just be the top half of it. Now notice that this inequality does have an equal sign, so that means the circle is solid, but the other one is just dashed. Now this y is below that circle, so you're going to have the area that's shaded to be below that circle. So now let me ask you a question. What area is it that's above the dashed line but below the red line? Well, it would be this area and this kind of like ice cream cone shape right there. Anything that's within this area is above the first graph and below the second graph. So that's the solution to the problem. So it's just a multiple choice question, so you just pick the one that looks correct. All right, now let's do number 12. So number 12 says to graph x is greater than or equal to 0, y is greater than or equal to 0, x is less than or equal to 2, and y is less than or equal to 3. So x is greater than or equal to 0 is just this line right there, and you're pointed toward the greater than side, which is to the right. And y is greater than or equal to 0 is just a horizontal line of 0. But it's greater than or equal to that, so it's going to be pointed up. X is less than or equal to 2. X is less than or equal to 2 is just a line that goes through 2, 0, and it's vertical, but it says less than it, so hold on. So it says less than it, so it's going to be pointed towards the left because x values that are less than 2 are towards the left of 2. Then last but not least, you have a y less than or equal to 3. So less than or equal to 3 is like up there. And so it'd be up there at going through the point 0, 3. And but it says y is less than or equal to 3. So you're going to be below that. So now after you've graphed all 4 of those lines on the graph, then you're going to shade the area that's correct, which is the area to the right, and then the left, and then below and above. So you're going to shade the area that's in the middle of all 4 of those graphs. And then it says, what are the vertices of the region? The vertices are the corners. So the vertices of the region are, let me write them down. The vertices of the region are, I'm going to start from the first corner down there. So the vertices are 0, 0, and then that point, 2, 0, and then this point, well, I guess you'll go to that point, and then 0, 0, 3, and then that point last. That point is equal to 2 for x and 3 for y. So that point is 2, 3. So, and of course, don't forget to put commas between these answers. So those are the vertices of the region with commas between them. Now let's try problem 13. So Problem 13 says to graph x is greater than or equal to 0, y is greater than or equal to 0, and then 5x plus y greater than or equal to 15, and then x plus y greater than or equal to 11. So you're going to have a graph for this. And the first graph, of course, x is greater than 0 or equal to 0 is just a vertical line through 0. The next one, y is greater than or equal to 0 is a horizontal line through 0. The next one is interesting. So if you carefully look at that one, 5 times what equals 15 would be 3, right? So x would equal 3. The x-intercept is 3, so 1, 2, 3. Go there. And then if you just look at y, what equals 15? It would just be 15, right? So you just get y equals 15. So y is equal to 15. That's the intercept of that. So that line will go through those 2 points, and so it looks like that. Then you graph the last equation. So this one is also interesting. So if you just look at x, say what equals 11, you just get x equals 11, right? So the x-intercept of that one is at 11. Then if you look at y and you just say what equals 11, you just get y equals 11. So the y-intercept is 11. So this other line kind of dips through that line like that. See that? Now you'll be able to see this on the computer more clearly. But on the computer, now also, by the way, you have to shade the area towards the right of x is greater than or equal to 0. So that would be this way, right? And then and then you'd shade the part that's above this line, right? Above that one. And then you'd shade the part that's above the first line we drew, which is the blue line. So above the blue line, looks that way, right? And then we'd shade the part that's let's see, we shade the part that's above the other line too. So above this line as well. So where are we going to shade? Well, we're going to have to shade the part that's like above all of those lines. Well, the only part that's above all of those lines is out here, right? Now notice it hits the black line until it gets to this corner, and then it's going to turn and only hit the blue line. So the computer will do that automatically for you if you just click over in that area. Now we have to find the vertices of this region. So the vertices of this region are that first red dot, then that dot right there, and then that dot right there. So the vertices are starting from the, let's start from right here. If you look carefully at the graph, that point right there, that red dot where they cross, you look closely at the computer graph, it'll be crossing through 1, let's see, 8, 9, 10, 12, 110. So 110, you'll have to look at it on your computer graph to find out for sure, but my graph is crossing through 110. The next point it's crossing through is right up there, the vertex, so it'd be 0, 15. And then the last point is down there, 11, 0. Now, you might ask yourselves, why isn't this point down here, why isn't that point a vertex? That's because it's not touching the yellow region. So only the corners that are touching the solution are called vertices. So those are the vertices of this problem. So that's question number 13. Now, let's do the last problem, which is question 14. It's kind of a short test. Wow, I thought there might be another problem. So it's exciting. We're almost done. Okay, so problem 14 says to Find the function that says t of xy equals 3x plus 4y. Actually, it just gives that to you. And then it shows you a graph like this. And it says boom, 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 0, 7, 4, 4, and a 0. And so what this says is find the maximum, not the maximum, find the minimum value. Find the minimum value of this on the given region. So find the minimum value of this on the given region. So let's see. Actually, no, I don't think that's the right region, actually. I believe that the region is actually out here. So what's the minimum value of that function on that region? Well, it has to be at one of those vertices. So the only options you can choose from for the minimum are either going to be t of the first point 0, 7, or t of the second point 4, 4, or t of the last vertex, which touches the shaded region, which is a 0. So t of 0, 7 would be just 3 times x plus 4 times y. So 3 times 0 plus 4 times 7, that's 28. And then t of 4, 4 would be 3 times 4 plus 4 times 4. That's 12 plus 16, that's equal to 28 again. And then t of 8, 0 would be 3 times 8 plus 4 times 0, that's equal to 24. So which of those is we're looking for the minimum. Which of those is the minimum? So the answer is 24. So the minimum value of the function is 24 on that region, on any of those vertexes that touch that region. So that's the end of your review for your Chapter 5 test, and very best wishes to you. I hope you all score a perfect score. And good luck.